Okay, let's jump right into this explainer. Today, we're tackling a concept that completely defies our everyday intuition about how the physical world actually works.
So, here's a question to kick things off. If you walk up to a solid brick wall and push against it as hard as you literally can, does the wall actually push you back? I mean, it sounds kind of weird, right? But the answer to this actually unlocks one of the most fundamental rules of the entire universe.
To figure that out, we have to look at Newton's third law of motion. The formal definition says that for every action, there is an equal and opposite reaction. Basically, there's this perfect built-in symmetry to how forces operate. The absolute most crucial thing to remember here is that forces never, ever act alone. They always exist in what we call interaction pairs. And the real kicker? These paired forces happen to two completely separate things.
Let's break this down with a real-world scenario, going right back to your hand pushing against that brick wall.
This brilliantly illustrates the law in action. The action force is your hand pushing the wall forward. The reaction force is the wall actively pushing your hand backward. They're exactly equal in magnitude, meaning the amount of force, but they point in completely opposite directions. Now, what's wild is how this exact same rule applies to something you do every single day, like just walking across a room. Think about it for a second. You don't just magically propel yourself forward. Your foot actually pushes the ground backward. That's your action. In response, the ground actively pushes your foot forward. That reaction force is literally what moves you down the hallway. We see this exact same interaction pair in fluid dynamics too. Take a swimmer moving rapidly through a pool. The swimmer only moves forward because their hands cup the water and push it backward. And the reaction? The water pushes back against their hands with the exact same amount of force, shooting them through the lane. Okay, time for a quick cause check to make sure we've got this locked down. If a baseball bat hits a ball with 500 newtons of force, what is the reaction force? Think about it for a second. Did you get it? The baseball pushes back on the bat with exactly 500 newtons of force. The magnitude of that interaction pair is always perfectly equal, no exceptions. But wait, this brings up a huge, glaring question. If the forces are perfectly equal, why does the baseball go flying out of the park while the bat just slows down a tiny bit in the batter's hands? To solve this mystery, we need to look at what happens when you jump straight up into the air and gravity pulls you back down. Believe it or not, you actually pull on the earth just as hard as it pulls on you. But because you have a relatively tiny mass, you accelerate quickly back to the ground, while the enormous mass of Earth has an acceleration so incredibly close to zero that it doesn't noticeably move at all. To really cement this concept, imagine an ice skater pushing off a rigid wall at a skating rink. That equal force is applied to both the skater and the wall, but the skater's much smaller mass means they get a rapid acceleration backward, gliding across the ice, while that heavy, anchored wall doesn't budge an inch. The big takeaway here? Equal force absolutely does not mean equal acceleration. All right, let's shift gears and rapidly bust 3 extremely common mistakes that always seem to trip students up when drawing free body diagrams for these interaction pairs. First up, never, ever draw both forces on one single object. A free body diagram only maps the forces acting on a specific target, not the forces that target is exerting on something else. Keep them separated. Second, because these paired forces act on 2 entirely different objects, they can never mathematically cancel each other out to zero. They just aren't fighting each other on the same body. And third, just like we saw with a skater, do not assume that equal forces mean the objects won't move. Equal force still creates movement because, as we now know, acceleration is completely tied to mass. Time to test that memory. Pause check number 2, and I'm challenging you on this one. Why do action and reaction forces never cancel each other out on a free body diagram? Because they always act on 2 completely different objects. That is the foundational standard you have to remember here. So, to quickly recap everything we've covered in this explainer, forces always exist in pairs. They always act on different objects. And acceleration depends heavily on mass. Now, let's put these rules to the ultimate test with a seemingly impossible scenario. If a rocket is in the vacuum of space with no air to push against, how does it accelerate by pushing exhaust gas backward?